Okay, here's a horizontal asymptote example that I would like to do. The limit as x goes toward, this is positive infinity here, okay? The same result would actually hold if I went to negative infinity. Um, yeah, it would hold, but let's just go to positive infinity. This is enough to establish by itself horizontal asymptote. Of course, negative infinity, the fact that we go to the same thing as we go to negative infinity is just an extra bonus. Okay, but anyway, limit as x goes to positive infinity of this numerator over this denominator. You can't just do you can't just set the limit of the quotient equal to the quotient of the limits because you'd have infinity over infinity. What we have to do is an algebraic trick. We divide the numerator by x to the fifth and the denominator by x to the fifth. We pick the highest exponent term, which is x to the fifth, when we do this. Okay, so just the x to the fifth. We don't want the coefficient in front. So x to the fifth here and x to the fifth here, okay? Now, and then you break up the fraction by algebra. You can break it up, or arithmetic, however you want to look at it. And then, but remember by the law of exponents, x to the fifth over x to the fifth cancels, just leaving you with 7. X to the fourth over x to the fifth is just 1 over x, but, well, 2x to the fourth over x to the fifth would be 2 over x, and the negative sign. So negative 2x to the fourth over x to the fifth would be negative 2 over x. And then positive x cubed over x to the fifth would be positive 1 over x squared, so plus 1 over x squared. And then in a similar fashion, minus 9 over x cubed, you do 5 minus 2, but since the bigger guy 5 is downstairs, your x cubed goes downstairs, so it's 9 over x cubed. And then in a similar fashion, minus 6 over x to the fourth. And the minus 4 over x to the fifth, there's nothing to do with it, so it just comes down. Now, and down here, in a likewise fashion, we get 10, and then we skip a few terms because they're not there. Then we get 8 over x cubed. Well, actually, we just skip the x to the fourth term, don't we? But anyway, so we get 8 over x cubed, minus 3 over x to the fourth, and then plus 5 over x to the fifth. Actually, no, we take it, as far as what we skipped, I take it back. Everything I said is correct except for what we skipped. We don't have anything over x squared, and we don't have anything over x to the 1. So there's 2 terms that are missing in the middle here, not just 1. So my bad. But lo and behold, guys, hey, neither one of, as x goes to infinity, positive infinity, neither one of these guys go to infinity or 0. We're home free. We can now set the limit of the quotient equal to the quotient of the limits, and we do that right here where my cursor is. Okay, and just to show it off, I break it up. The sum and difference of the limit is the limit of the sums and differences is the sum and differences of the limits. So I break it up like this, top and bottom, numerator and denominator, that is. So here and here. But then, just to show it off, I take out a constant. Remember, in the limit, you can always yank the multiplicative constant out to the side, like the 7 out to the side, the 2 out to the side, and so on and so forth, the 9, and we get the idea. But hey, the limit as x goes to infinity of 1 over x, or 1 over x squared, or 1 over x cubed, or any of these is just 0. 1 over x to any positive power, that limit as x tends to infinity is 0. So this is just, these terms die, basically. So now the limit x goes to infinity except for the first terms. All the terms, now this 7 term survives, but these other terms to the right of it die. And downstairs the 10 term survives, but the other terms to the right of it die. So we get 7 times the limit x goes to infinity of 1 is just 1, so 7 times 1. But the other limits aren't 1, they're 0. In the similar fashion down here. And so we just get, by PEMDAS, we just get 7 and a bunch of zeros, and 10 and a bunch of zeros, so we just get 7 over 10. Hence, y equals 7/10 is a horizontal asymptote of our original function, f of x equals this numerator over this denominator, which is the guy, this is right here is the guy we had in the first place. We took the limit x goes to infinity of f of x, we got 7/10. So 7/10 is a horizontal asymptote. And you could actually replace infinity with negative infinity in all these, and you'd get the same guy, 7/10. But we don't, that's overkill. We've already established, just by using, say, positive infinity, that 7/10 is a horizontal asymptote. And that's all I wanted to do in this video. I wanted to augment horizontal asymptote because this is an important example that doesn't need to be skipped. Thank you. Bye-bye.